Hey everyone, this is Zach, and welcome to the channel. Today I have a special guest, Sid Palas, who has his own YouTube channel called DevOps Directive, where he helps individuals on the internet and companies build better DevOps pipelines and get their apps to cloud infrastructure. And today's discussion is going to be an awesome one for anyone who's kind of at the beginner to intermediate level. Maybe you've, dived into DevOps a little bit, but you're looking to get a better grasp on what it's all about, what is a DevOps engineer, and what is their job, and how you can kind of expand your own software skills to be a more well-rounded developer. So I will start this off by asking Sid a little bit more about himself. Go ahead, Sid. Tell me what your DevOps Directive channel is all about and what people can find there.
Yeah, thanks for hosting, Zach. I'm happy to come on the channel. As you mentioned, I run a channel called DevOps Directive, and it's really all about helping people level up their DevOps and cloud infrastructure skills. So I cover a range of technologies from infrastructure as code tools like Terraform to Docker and containers. I just released a big Docker course on my channel. So if you want to really do a deep dive, I've got a 4.5 hour video covering everything you would ever want to know about that technology.
Drop
So
the
yeah,
link in the description for that, by the way,
yeah,
so you
for
can
sure. We
find
can
that
we can
below.
put the link there. And so yeah, I try to hit all the different aspects of DevOps, and I think we'll talk more about what DevOps even is here in a minute. But on my channel, I try to break things down and do really in-depth tutorials around the technologies and practices associated with it.
Cool. Well, yeah, that's a good segue. I think we'll start off with kind of a basic definition. Let's assume that you're a complete beginner and everyone's at least touched DevOps either directly or indirectly if they're writing software. But how would you define a DevOps engineer? And then maybe you could walk us through what that job title might look like at, maybe doing side projects for yourself, working at a small startup, all the way up to a large organization. What does that title look like? What are those people doing?
Yeah, I'll answer that in thinking about it from the lens of I know a lot of your audience are coming from the web development side of things. DevOps is a combination of two words, right? Development and operations. And historically came from this world in which companies would have an organization of developers who are writing your application code, and then an organization of operators or the operations organization who are racking and stacking servers and configuring the networking and taking the deployable artifacts that the application teams are building and figuring out how to run those on that infrastructure. And so historically there was this divide, and DevOps is the idea of how do you bring those two pieces of work closer together to make them both more effective. So if you can have the application development team understand the context of where their application is going to be run and how that's going to work, and if you can have the operators understand more about what the application is doing so that they can tune the infrastructure accordingly. That's what DevOps is really all about, bringing those two functions closer together. And that manifests in a number of ways, ranging from CI/CD pipelines are a very common use case that people think of when you think about DevOps, and that's continuous integration, continuous delivery, or deployment. Depending on who you ask, the D stands for one or the other. We're not going to get into that here, but effectively, how do you take each incremental change that you're pushing to your application, and how do you get those changes built and deployed into your production environments and into the hands of the users? And so automating a lot of that with CI/CD is one aspect of things. I think understanding how to build repeatable environments such that your development systems and your deployment or production systems are as close to one another as possible is another aspect of DevOps, and how you can sort of ensure that best practices are followed throughout the entire software lifecycle, sort of baking those into your systems through infrastructure as code and that sort of thing. Those are all examples. I think DevOps is more of a mindset and a methodology rather than specific technologies. But those are specific examples of what it might mean in a particular organization. And then you asked about the title DevOps engineer and what that person may or may not do in various organizations and at various scales. I think DevOps engineer is an interesting title, and a lot of people find it somewhat controversial because historically DevOps was a practice that a team would implement rather than a singular role that one person would go off and sort of do DevOps. In the past, I don't know, 5 years, many people have started using it in a slightly different way where they do have a singular person going off and implementing CI/CD pipelines. They're calling that a DevOps engineer. And so I tend to be, I don't mind when people use the term DevOps engineer, but I think thinking about how you as an organization can apply DevOps practices is more useful than saying, okay, you are Mr. or Mrs. DevOps and are going to go off and do all the things. And sort of instead saying, how can we help to teach the developers on our team these different aspects of how their applications are built and deployed and run such that they can write better software faster. At a small company, all of these types of tasks around automating and building and deploying your software may fall into the hands of lots of people within the team. Within a startup, people are oftentimes generalists and sort of everybody has to wear a lot of hats because you don't have enough people for each person to specialize in one aspect or the other. And so you often end up touching a lot of these different types of systems, regardless of whether your title is software engineer or DevOps engineer, et cetera. But as you go to a larger and larger organization, your role often becomes more and more specialized. So now, because there's enough people and because you are now serving likely a much larger user base, the performance considerations for your software become much more stringent. So you need the expert in this particular technology in order to squeeze as much performance as you can get out of that particular system. And so I think there's this whole spectrum from one man or woman entrepreneur who needs to do it all the way to hyper specialized within a massive enterprise, really focused on, I'm the expert in optimizing Postgres performance specifically, and that's all I do, right? And so I think there's a whole spectrum between those two. Depending on where your organization is along its journey, you might fall anywhere along that.
Right. Yeah, I like how you mentioned how it's more of a mindset because that's how I've always viewed it as well. You talk about a dedicated, DevOps engineer. And while at larger companies, yes, that may make sense to have someone in there who's making sure that, the pipelines are great. It's a great developer experience for everyone who's actually writing the code, kind of takes that weight off their backs. Like that's a great thing. But at the same time, you go to a smaller company, like you mentioned, and oftentimes, maybe you'll disagree, but it seems like the role of DevOps is more of a one-time thing where you get in there and you build out a pipeline that works for the team that's writing the code and gets the job done. And then once that has been written, then it's everyone's, every software engineer should be able to understand, what stages that pipeline's going through. If we're running some unit tests, integration, maybe even some end-to-end tests against staging or production. I think it's advantageous for each software engineer to understand that and be able to contribute to that. If they wanted to, if you are solving for a bug and you want to add a test to make sure it doesn't happen again, feel like it's pretty important that you also understand, where those tests are being run against the code base. So what would you say that that's somewhat accurate in terms of, it being like, obviously you have to maintain a pipeline over time, but a lot of the effort comes up front when you're trying to just build the experience at the start.
Yeah, I think there is a big, I'll agree that there's a big chunk of work when you're initially setting up a company and all the systems around your software focused on DevOps and getting the tools in place to have the developer experience be streamlined. I think I'll disagree slightly in sort of specifying it as you build it and then you're good to go. I think instead I would think about the types of metrics that you care about as a team. There's a research report that I think Google funded and an organization called Dora put out each year. And we can link to it in the description, that kind of calls out how different teams perform in terms of their DevOps systems. And it calls out 4 key metrics. So let me just pull up what those metrics are so that
Yeah.
I don't mess them up. Yeah, so the key metrics that they call out are: one, deployment frequency. So how often you're pushing
Mhm.
new versions of your application into the hands of your users. Two, lead time for changes. So how quick can a change go from a developer laptop to production? Three, the mean time to recover. So if you do have a bug or an incident that causes downtime or an issue, how long does it take on average to fix that? And then the fourth one is the change failure rate. So how frequently with each new application version do you have an issue and need to roll back or make some type of change? And so I think the work you described about building out these pipelines help to address each of these different metrics. But ideally, you're tracking these over time and understanding, hey, as my code base has grown, as I've added additional tests, am I still hitting the lead time for changes metric that I used to be? Like by default, sort of things are going to get slower over time. You're adding more code,
Right.
you're executing more lines of code, and so if you do nothing, if you set it up once and forget, you'll sort of start at some level of performance and then just sort of slowly degrade over time until it becomes painful enough that someone says, this pipeline's taking 2 hours
Yep.
to run. Why is that? And so instead, sort of trying to be proactive about it and tracking these types of key metrics that can be an indicator of the DevOps health within your organization then allows you to make informed technical decisions of, should I be investing in this new technology or this new approach, or adjusting how we're doing things to help improve one of these aspects to help ramp up quality of life for the development team.
Yeah, so a couple points I want to piggyback off here. I love how you're talking about, this a living, breathing thing. Now, going back to the roles that we defined, let's say that, you've set your initial pipeline up. Someone's come in, maybe you hired an outside contractor to come in and just set something up for you. And then over the next 6 to 8 months, the code base grows, as you were talking about, and you write a bunch of end-to-end tests, and all of a sudden your time to deploy goes from, let's call it, 3 to 5 minutes all the way up to 25 minutes. And at that point, I think, I'll let you kind of chime in on what threshold you think, a company should be at, maybe depending on the size. But at that point, it's going to start to get painful for the people writing the code. So who comes in and changes that and updates it? And, obviously that's going to vary per company, but in terms of best practices, what you think, would be the right approach, how long should a time to deploy be, and who do you bring in to fix it if it gets too long?
Yeah, I think faster is better. So I'll start with that. I think the threshold of where it becomes painful enough that you're going to focus effort on streamlining it versus on building out more features or fixing other bugs is obviously going to depend on the specifics of your business and the priorities of particular milestones that you need to meet, etc. It's just like any other tech debt. It can be hard sometimes to prioritize it over the new feature releases that are going to bring in additional users or dollars or what have you. And so setting that threshold is something that you and your team will have to think about and say, hey,
Yeah.
how much time am I wasting each week because it's taking this additional 20 minutes to deploy and I'm losing context, and now when I go back and there is a bug, I can no longer even remember what I was doing because I've already switched to a new thing. I think finding that threshold is going to be unique to each company, but off the top of my head, saying over 30 minutes feels about right for where,
Yeah.
hey, now I merge my code to the main branch. It's going to go off and deploy. If I can't now see if there's any issues within that first half hour, by then I'm going to already be off working on something else. And so that context switching can be a huge productivity hit if you do need to ever come up with an issue. So 30 minutes is sort of a ballpark estimate. But yeah, I think it's gonna depend on your current
Yeah,
business priorities
more
for
of
sure.
a business metric that
Exactly.
the team's responsible for defining. I know at this, I've worked at some smaller companies, and I think at a smaller company, you want, we're trying to get that under 10 minutes so that we can, push changes really quickly. And if there's like a hot fix that we need to push out, we want to be able to see that go live very quickly. But, obviously large organization, slower, you have to deal with that. Now, kind of changing directions a little bit, we've been talking about this idea of a pipeline. And you had mentioned earlier the concept of environments. So if, I'm just getting into this profession, trying to understand, what are the environments that we actually need to set up, and what should be included in one of these pipelines. Like what are the key elements of a continuous integration and deployment pipeline? What would you say for that? And then maybe, I know I'm throwing a lot of questions here at you, but let's go ahead and start with what is it? What is a pipeline? And then we can dive into some of those details.
Sure. Yeah. So when people talk about pipelines, generally they're referring to a sequence of steps that are going to be performed on some remote server. And the purpose of that pipeline can depend from one to the next. You might have a pipeline that runs every time you push to a Git branch for a new feature that you're building. And that pipeline might build the code, lint the code, and run your tests. So make sure that it produces a buildable artifact. Make sure that you're following all your linting rules for whatever particular language you have configured. And then if you have a test suite, hopefully you do, run those and make sure that they all pass. That could be one pipeline, sort of an integration test pipeline.
Mhm.
Then you might have a separate pipeline or a different pipeline that is going to perform some other actions. And that could be maybe when you merge that pull request back into main, let's say it's going to build the code, it's going to run the test again. Why not? Make sure things are still good to go. And then have an additional step at the end where now you're going to take whatever artifact you've built, whether that is a container or if you're in Java, maybe it's a jar file. If you're in Go, maybe it's a binary that you've compiled, and ship that off to some server where it's going to be run. Could be to a staging environment, could be to a production environment, and so that's this concept of a pipeline. There's a number of different providers out there. You may have heard of GitHub Actions, which is built right into GitHub. You can very easily write up a configuration to do the types of things that I was describing. GitLab has their own CI/CD pipeline tool built in. There's Circle CI. There's a number of different tools out there, and a lot of them are quite similar. But in general, you're defining a set of actions that are going to be taken in sequence that are going to happen upon specific events. Those can be pull requests, merges, push events, any event that you can track within your version control system within Git, you can usually trigger one of these pipelines on. And so that's the concept of a pipeline. I forget the next piece of the question.
Yeah, no worries. So we got the pipelines down. The goal there is to take a change that you've made within the code base, and upon a new commit to a separate branch, you might run some tests to verify the pull request before it's reviewed by another developer. And then when you merge that pull request into the main branch, you might have a separate pipeline that runs, that does some verification, runs some tests, maybe does some end-to-end testing, and then deploys to a server. So we've got this pipeline written out. Now, in your opinion, if you're on a small team, let's say you're on a team of 4 or 5 developers who are reviewing each other's code, what kind of things do you think would be the bare minimum for a pipeline that runs on a pull request? So, developer pushes the code up to GitHub on a branch. What are those individual steps that you would want to see run, making that trade-off of, you want coverage, but you also want this to be quick so that, reviews can happen quickly?
Yeah, I think bare minimum, you want to validate linting and run your test suite. I think the gold standard and and we haven't even touched on sort of platform as a service, the concept of platform as a service yet, but the gold standard would be to have a ephemeral temporary environment that gets spun up automatically with each pull request, such that the reviewer can click in and actually see your code running live on a server, see the changes, interact with them. That would I think that's beyond the bare minimum, but comes out of the box with a lot of these platforms as a service. If you've ever used something like Vercel,
Right.
when you push code to a new branch, it gives you a magic URL that has that code running live, and sort of that makes it much easier for someone to interact with your changes and understand whether they are meeting the bar for what they're supposed to be doing.
Right. So in terms of, you say tests now, I think we can obviously we can break this down into 100 different categories, but let's go with unit, integration, and then end to end. That'll be our three categories. Unit tests are obviously going to run first. They're the quickest, and you can get that, fast failure if that is, if you have a bug in the code. Then you run the integration test, which will need some sort of backend in some cases, as well as the end-to-end test. Now, tell me, in terms of like with these platform as a service, it's obviously, you've got a single page application. It's relatively simple to get those, deploy URLs. But what happens when you have databases running? Are you trying to spin up separate databases and have a single database instance for every single pull request? Or do you have, one staging database that all the pull requests are going to kind of share? How do you think about that? I think that's a challenging thing for a lot of companies that are, trying to get an efficient review workflow, and trying to deal with, pull requests kind of battling each other to, update the staging database.
Yeah, I think creating a separate database for each ephemeral environment will help alleviate that issue at the expense of complexity and cost of the resources for
Right.
running those things. And the challenge, there's obviously this tension between wanting your test environment to be as similar as possible to production, but not wanting it to cost the same amount as production.
Right.
And
Right.
so, like, the perfect test would be to have an exact replica of production and all the data and run against that. And for certain aspects, if you're testing specifically performance against load, that is almost necessary to achieve what you want. For many other purposes, it is not necessary at all to have the full data set and the full production database running wherever it needs to be running. And instead, you can have a almost empty database with just a little bit of seed data to replicate the interactions that you care about. And that could be run in a container, and we haven't even touched on containers yet, but it could be run on a container somewhere in a much more lightweight fashion, such that you can afford to spin up a new one with each ephemeral environment. And because of that, you're able to make database changes in those new environments without having that conflict, like you were saying.
Right. Yeah, so in terms of like, a scale of the bare minimum that you'd want to see to the gold standard, the bare minimum might be everyone, all the developers run local environments just on their computers. There's nothing going on in the cloud there. Then you might have a single staging environment that's, got one database that all the pull requests hit, all the code kind of runs on. And then you have production, of course. Is that kind of a accurate representation of what you'd call like the bare minimum? And then, as you were talking about with gold standard, that's to the point where, local development environments might even be in the cloud, right? Is that kind of a fair assessment?
Yeah, I think you can have develop remote cloud-based development environments. Could be one solution. You could have container-based container-based development environments to help the code running on your laptop more closely represent the
Right.
environment where it would be deployed into. I think you mentioned this staging environment. A pattern that a lot of companies follow is when you when you merge to main, you deploy to staging, and then deployments to production are a sort of manual trigger. Let's say
Right.
I merge my code to main. I look that it's doing fine on that staging environment. Then I go either issue a GitHub release or click the button on triggering the deployment pipeline. And now that code gets promoted to production.
Mm.
That's okay. I think it's a little bit of an anti-pattern. If you can get away with automatically promoting, that's much better, because we talked about that
Mm.
time to deploy, keeping it short.
Yep.
Adding in this gate at staging with a manual step to deploy just sort of extends that time significantly from when code is on your laptop to when code is in the hands of users. And so I think, as if you can do it, getting to the point where once you merge to main, that code's going out to production. And that requires a level of confidence in your test suite,
Right.
such that you are okay with that happening, versus wanting to go test it out manually in a staging environment before you're willing to ship it.
Now, I'll ask you your opinion on this one because I think it's going to be different depending on who you ask. But how do you feel about that concept of you know, trusting your test suite and just going by this concept of we auto deploy everything, and a failure in production means that we didn't write our test well enough. We need to plug that hole and make sure that we have better coverage. What's your take on that? Is that a good practice in today's world, or is there something else that you'd recommend?
Yeah, so there's one additional piece to the puzzle that I think can help give you the best of both worlds. You can deploy on every push to main and not have to trust your test suite fully. And that is this concept of feature flags. So a feature flag is the ability to turn on or off some new feature or code branch at runtime without having to redeploy. And so by doing that, you can decouple the deployment of new code with the release of new features. And so let's
Mm-hmm.
say I'm working on some new feature. It's really tricky and gnarly, and I'm not sure that I got it right 100%. There are tools out there, or companies build their own tooling to do this as well, that will allow you to deploy that new feature, but it's turned off and nobody actually sees it. And then you'll have some interface where you can say, okay, I want to enable this for internal users only. So maybe only people who are at the company testing things will get this new feature, and I can go in and manually test it. Or once you've reached that level of confidence of, okay, seems to be working when I test it out, when my colleague tests it out, maybe I'm going to release it to 5% of end users. And now I can toggle the switch. 5% of people start seeing it. I can watch the metrics and see how it's performing, whether they're hitting issues, whether we're running into performance issues, and then toggle it off if I see issues, or ramp it up and eventually get to that 100% rollout. And so I think that concept of feature flags allows us to move and decouple, like I said, decouple the concept of deploying new code with releasing new features. And that makes it such that while you want to have a good test suite and you want to make sure things are rock solid, it allows you to keep the ball rolling, even if there's a potential issue, because you can toggle it off, fix it, and then make the necessary updates.
Right. Yeah, that's a great point, and something that I had not brought up to this point, the feature flags. So, in your Docker course that you just released, I know you have a section on the history of everything and history of containers. So I'm sure you've spent some time, digging into how organizations have evolved their, pipelines and deployments over time. And it sounds like to me, as we're kind of talking here, that we're moving away from this idea of having, a permanent staging environment, more towards this, I think, correct me if I'm wrong, but more of a trunk-based development type of workflow, where instead of, trying to come up with this totally separate staging environment, you just pretty much commit everything directly to main, or at least have pull requests that are not long lived, to the point where they're very small, easily reviewable, and they never, sit out there for more than a couple of days. And by doing that, you're kind of pushing the focus on getting your low risk changes into main, and getting that deployed behind, let's say, a feature flag as quickly as possible. And, the idea there is to speed up development. Is that kind of a good summary of where you see the industry going, and is there kind of a next evolution of that?
I think that's a great summary of the sort of the ideal of what we're trying to achieve. I will caveat it with the fact that I'd say a majority of companies that I work with are not there.
Hmm.
They still have this long-lived staging environment. They may or may not be promoting a code from staging to production automatically. Uh, Feature flags are they add a lot of value, but they also are a complex thing to implement and utilize. And so I think oftentimes when you're first starting out, it is not necessarily worth it to go set up the perfect system where perfect is the enemy of good,
Hmm.
or done, or I forget the exact phrase, but instead getting something that is good enough and allows you to move quickly and build and ship your product is more important than having the ideal DevOps setup where everything is fully tested and you have feature flags and you're doing trunk based development. And so I think sort of getting up and running quickly is paramount in the first stages of a company where unless you're making money, you may not exist in a year. And so it's more important to get the features out that are going to bring users and bring that cash flow than fiddling around with optimizing the system. And to that point, I think a lot of companies starting out would do very well to start on a platform as a service offering, something like a Google App Engine or Vercel if you're using Next.js, or Elastic Beanstalk on AWS. Like there's a number of platforms out there that give you a ton of nice tooling and automations, and those CI/CD pipelines that we were talking about, they come out of the box where you push code and they automatically build and
Right.
deploy it for you. Railway is another one that has a really nice user experience for automatically handling a lot of this stuff.
Right. Yeah, and I mean, I'm guessing that would be, your recommendation to anyone who's doing a side project or, building a startup kind of in the early stages. The platform as a service is pretty much the way to go in terms of, the modern day DevOps, right?
Yeah, I think as long as you can get away with it, and there's two sort of pieces that are going to push you away from using a platform as a service. The one is the way that they are able to provide that magic is they constrain what you can do. And so like Vercel is super optimized on Next.js and building applications using their particular opinionated technology stack. That's great. If that's what you want to use, it's perfect. Go for it. Eventually, you may need some functionality that is beyond what they offer. And I know they just added a whole bunch of capabilities around
Hmm.
storage and
Right.
whatnot last week, but still, eventually, you may have some need for a, a, a requirement in your technology or in your application that is not met by the technology offerings that they provide. And that's where you have to think about, hey, do I need to use an offering from another service or platform to fill that gap? And once you have enough of those pieces that no longer fit within the box that they're providing, then you may want to move and sort of build out a more holistic system on AWS or GCP or what
Right.
have you. The
One of the examples there, if I think from my past, I've seen compliance can be a thing that can drive you to one of those bigger platforms where, some of these platform as a service may not be SOC 2 compliant or whatever other industry that you are writing an app for. And that might be one of the driving factors, just from my experience.
Yeah, for sure. Compliance or things like maybe you need a message queuing service.
Right.
So I want to decouple the processing. Let's say I'm doing some big image or video processing stuff that needs to kind of happen in the background. And I want to offload that from my main web app and have that run as workers in the background. There's a whole piece to that may or may not fit within the particular confines of your platform as a service.
Right.
That's just one particular sort of architectural pattern that might not fit. I'm sure there's plenty of others that people can think of. The other, so I mentioned there are two things that might push you away from platform as a service. The second one is pricing. Like they offer this really great developer
Hmm.
experience, and they charge you a premium over the base level compute resources that you would be using. And so once you reach a certain tier, and for many companies, They may never reach that tier. And so it's fine to just keep paying whatever it costs. But sometimes you do get beyond the point where now it does make sense to invest in an engineer's salary to go off and solve these
Mhm.
problems, build out our own custom systems to alleviate these same or to address these same types of developer experience concerns and DevOps systems. But if you think about where that threshold is, engineers' salaries are expensive, and so you're probably going to be paying on the order of $100,000 a year or more to this company before you start to think about should I start to pull some of this in house. And so you have to be using it quite a bit to get to that point.
Right, right. So there's a trade-off there, and yeah, because many of these platforms as a service, like Vercel, Render, you had mentioned a couple others, they're just built on top of GCP or AWS. So I think Renders may be built on GCP, Vercel's on AWS, so they pretty much have to charge that markup. So it's a very good point of, for most people, most people watching this for that matter are probably going to be fine on platform as a service like Vercel. But yeah, once you get to the point where, you have an app that lots of people visit on a daily basis, then there's that trade-off of, do we need to move on to a more custom solution?
Yeah,
So,
the one other piece I'll chime
yeah,
in with is there's a little bit of an in between where two companies, excuse me, that I'll mention are Flight Control .dev, I think, and Zeet.co, both
yep,
of which sort of provide a user experience layer on top of the hyperscaler cloud. So let's say you're still deploying into your main AWS account or your GCP account, but they provide some of that same tooling that a platform as a service might provide around automation and building and deploying your code. And so that could be kind of a hybrid between the two where you are still deploying onto one of the main clouds, but you get some of the niceness out of the box and don't have to build all this from scratch.
right. And so, like in a very specific example with Next.js, let's say you don't want to be on Vercel, and you want that cheaper compute that maybe AWS Lambdas offer, because those are a lot cheaper by a pretty big factor than the overage cost of that Vercel will charge you. So you're saying, something like flight control, SST, you said Zeit, all of these platforms would allow you to take something like a Next.js app, and it kind of gives you kind of some scaffolding of how you take the deployment output, with all of those functions, the API functions that you're writing in Next.js, and how do you get those onto, Lambdas or something like that? Is that pretty accurate?
Yeah, that's a good summary of it. And essentially, they provide, and I'm not sure exactly the matrix of which frameworks each of those tools support, but yeah, they support many of the major frameworks and enable you to have a similar experience where you connect your repo, you tell it you manage a few different configuration parameters, and then they set up a lot of the automation and deployment
And
resources
that's
for you.
almost, we won't get into it here because we're kind of hitting up against time here, but that would be a good example of infrastructure as code. Is that fair to say that they're basically using some of the, IAC, um, YAML or markup files and taking that and putting it in the middle of the developer and those more complex platforms that, have lots of stuff to learn that, developers may not want to dig into.
Yeah, so infrastructure as code, as you hinted at, is this concept of taking all of the configuration required to deploy your cloud resources and distilling that into some set of configuration files, whether that's YAML or some of them are code based, like Pulumi, for example, or CDK, use normal programming language that people are familiar with to define your infrastructure. I think the flight controls and the Zeets of the world are somewhere in between. They
Mhm.
do provide a configuration interface that is similar, but they don't always expose the full configuration that you could then use and
Right.
modify directly. And so there's a little bit of an abstraction layer there where you may or may not have full visibility into what that configuration would look like. SST is another thing you mentioned though, where they are, I believe, generating
Okay.
cloud
Is it?
formation on the back end
Yeah.
such that you would be able to see and interact with that full infrastructure as code definition.
Yep, they have some sort of escape hatch, I think, that allows you to dig into that. But to your point, these configuration specs are often pretty complex things, and especially if you're writing cloud formation, that requires quite a bit of experience to know exactly all those, parameters that you need to throw in there. Um, but moving on from this, just so that we can kind of start wrapping things up here, it's a good segue, talking about infrastructure as code, to kind of jump over to the container side of things, which is what you've been spending a lot of time on here in the last couple of weeks or months. So walk me through. You've just released a Docker course, and it takes you from beginner to really understanding the internals of Docker and what it's used for, and how you can leverage it to kind of automate a lot of things. So Docker also has a config file, Docker Compose, and so it kind of fits a little bit in that idea of infrastructure as code as well. And you had mentioned earlier that it's great. Containers and Docker are a great way to get your development and staging environments a lot closer to production. So can you maybe walk through, just give a brief overview of what Docker is and how companies are using Docker today to make their workflows easier?
Yeah, definitely. And so to first define what a container is, I think it's useful to step back 2 stages and say, when we first started with computers, you just ran your code directly on the computer. That's all there was. We now call that bare metal computing. If you're running your software directly on the system, people do this on their laptops, desktops all the time. You download something, you install it. That is bare metal computing. There's a challenge with deploying directly to servers in this fashion when you have multiple applications that could have different dependencies. And so let's say I'm over here and I wrote my application and it requires version 1.5 of some dependency. You didn't realize that and you used version 2.2 of that same dependency. Now, how do I deploy onto the same server? It just becomes a nightmare in terms of figuring out how to carve up the system and set the right environment variables such that those two things can coexist in the world. Fast forward a little bit, and people invented this concept of virtualization and virtual machines, where now instead of running directly on a physical server, you can use what's called a hypervisor that allows you to carve up those physical resources and install multiple virtual machines onto that one physical system. Each of those virtual machines has their own kernel, has their own operating system, and has their own version of all those dependencies. And so now I no longer need to worry about my dependency conflicting with your dependency because we have our own resources. So when you actually spin up a server on one of these cloud providers, unless there are some that provide bare metal machines, but usually you're creating a virtual machine on one of their systems. Virtual machines, though, are somewhat heavy, like because you're creating a whole separate operating system and kernel for each of these things. There's a lot of overhead there in terms of the resources they're consuming. And so fast forward a little bit further, and the concept of containers came around, where it's similar in concept to a virtual machine, where you have a isolated set of dependencies, and I no longer need to worry. I still don't need to worry about dependency versions, but instead of carving things up and deploying a separate kernel and operating system, now I'm actually sharing the kernel of the host and using some specific features within the kernel to provide isolation. And so it's a little bit more lightweight. You get a lot of the same benefits in terms of isolation, maybe not quite the same level of isolation guarantees or sort of battle tested, hardened nature that the hypervisors provide, but pretty well as long as you configure things appropriately. And so containers represent this lightweight method to bundle up your application along with all of its dependencies, and you could run that wherever. So now instead of needing to spin up a server with Ubuntu and do apt-get install on all these dependencies and copy my source code and do X, Y, and Z, as long as I have a container runtime, and there's a number of those out there. There's Docker has their own container runtime. There's Containerd. There's a number of others, and I provide a container image, which is sort of this bundled up thing. I tell that container runtime, hey, take my image and run it with these parameters. And now I should get a very similar, if not identical, performing application, regardless of where that lives in the world. And so it's boiled it down. So now rather than needing to deploy and install and configure all these things, I just need a container runtime running somewhere and my container image, and that's good to go. And so companies use this in a few ways. One, it helps to simplify and solve that dependency management configuration issue I was describing. But two, also on developer systems, you can run Docker locally because it's lightweight enough, or another container runtime. And now you can actually do your development with containers such that regardless of what I have on my laptop, whether it's running Linux, Mac, Windows, whatever you're running, it doesn't matter. We're going to get the same environment to test in. And that can solve a lot of issues that you might run into, subtle issues around how your language runtime performs slightly differently between different operating systems, et cetera. And so those are kind of the two main use cases of streamlining the setup of a development environment and making it close to your production environment, and then simplifying the way in which you deploy your applications by providing this standard interface that now I can go spin up a server with Docker on it, or many of these platform as a service providers behind the scenes are running containers. And so you're providing them with your code, they're bundling it up as a container image and deploying it. And so there's so many different ways you can deploy containers. And so it just kind of helps to level the playing field and make it easier and easier to be confident that your deployed application is going to behave the way you expect.
Right. It almost eliminates that works on my machine excuse. So, and also, in 2023, you'd probably say that pretty much any major cloud platform is going to have a runtime that can deploy a container. So we've gotten to the point, I think, it may not have been this way 5, 10, 15 years ago, where it was a mixed bag of where you were deploying stuff. But at this point, it's pretty safe to say that if you invest your time learning Docker, once again, Sid has an awesome course. You should go check that out. It's in the description to get started. But if you're learning Docker, that's a great investment because it's here to stay. Pretty much all of these big cloud platforms, when you hear buzzwords like Kubernetes on AWS, that's what CS is the equivalent offering. And all of these are running containers, which, as Sid had talked about here, it's basically you just take a file, define what you want your big computer to run like, and then you ship your code there. So, would you say someone starting out who maybe hasn't learned Docker yet, is that a good time investment, even as maybe a beginner or someone that's not going to have to deal with DevOps a whole lot?
I think sort of very beginning, prioritizing understanding how a web application works, independent of containers and Docker and everything, just sort of first really learning the fundamentals of, okay, I've got my client side code that's going to run JavaScript in the browser. I'm generally going to make some requests to a backend API somewhere that is running on a server, and that could be written in any number of languages. And then that that API is going to probably make calls to some database and get data back or write data to it. So sort of first prioritizing, just grokking like what the heck is even happening when I interact with a web application before going off and trying to learn containers. I think I would start with that. Then sort of containers and a little bit of just understanding, I guess before even containers, understanding how you would go about deploying your application without a container.
Mm-hmm.
So it's interesting. Like when people ask me, oh, how should I learn containers? I think oftentimes I say, well, learn how to do it without containers so that you understand why we want it and what the container is replacing. And so, for example, let's say I had that web application I was just describing. How would I get that in the hands of users? I need to take my code, and we'll just use Node.js as an example that a lot of beginners start with. I'm going to probably spin up a server. Let's say I go to Linode or DigitalOcean or Google, whoever. I create a virtual machine. I need to make sure that Node is installed on that machine. I need to make sure the version of that Node runtime matches the version that I used on my laptop. So I need to do node-s version over here and then say, okay, let me install the same version over there. Then I need to copy my source code to that server. Then I need to do an npm install or yarn install, whatever, to pull the dependencies just like I did locally. So I'm kind of recreating what I did locally on that remote system. And then I need to run my application. I probably want to run it with something like PM2 as a process manager, or I could just run Node and then index.js, whatever. Then I need to go check my firewall settings, right? And see if am I accepting inbound traffic on the ports that I care about? And so I think
Mm-hmm.
there's just all these little pieces that unless you understand conceptually what is happening and why the pieces fit together the way they do, I think Docker won't have a skeleton to hang on in terms of how you would understand it. And so I think getting those fundamentals down first and then moving on to pick up Docker can be a super valuable next step in terms of being able to leverage those benefits that I described. And so many teams, as you mentioned, are using container technology. Having that on your resume and as a skill that you can talk about, I think is really powerful in terms of being able to work effectively on these teams.
Yeah, I mean, I 100% agree. And a lot of the stuff on my channel here is kind of devoted to that question of why do we need this? What's the purpose? What's the pain point that this is solving? So in terms of Docker, I 100% agree. It's, you have to learn the ins and outs of, firewalls and, SSL and, just general deployment considerations. But you may get dropped into a code base at a company that they're already using Docker to maybe run a local Postgres instance or local Redis instance. How would you approach that as someone who is still trying to grasp those concepts that you talked about, but also has to interact with containers on a daily basis? What's kind of that survival path for that kind of developer? And what would you recommend that they go out and kind of learn first thing to just, keep them afloat?
Yeah, I think that's a great point to call out. I think you can get value from Docker and containers before you actually start containerizing your own applications. I have a whole section on this in the course where I talk about some of the use cases for third-party public containers before we even get to building our own. Databases are a great one where if I want an isolated database for my application, let's say I have multiple things I'm working on, I don't want to just have Postgres installed on my system. I can very easily, with a single command, spin up a version of Postgres, connect to it from my application, and I'm off to the races. And so I think you can spend an hour sort of going through this section of my course and come out ready to work with these third-party containers. I think there's one aspect of using containers that has some foot guns or some gotchas, and that is how data persistence works.
Mm-hmm.
And so containers by default are this ephemeral thing that you start up, you run, and when it goes away, any data you wrote inside that container goes away with it. There are two specific ways that you can store data that will persist beyond the container lifecycle. You can use volumes and you can use bind mounts. And so learning what those are, why the data goes away if you don't use them, and how to use them properly, it's really just a few options on your Docker run commands that you need to add. But I think understanding what's going on there, and like I said, I think it'll be pretty quick for someone to learn. But once you do that, now you can safely use these types of containers within your workflow and get the benefit from them before you've done the full how to optimize your container image for production kind of learning. The other couple of use cases, like the databases one that I use third-party containers for, is if I need to test something specific with a particular Linux operating system, like I need to figure out the command to install some package in Alpine Linux versus Debian versus Ubuntu.
Mm-hmm.
You can just create a container running that OS, jump into it, play around, get the command right, and then use that in whatever use case you needed. And then the third one is testing things with specific versions of language runtime. So everyone's had the issue where you've got 5 different versions of Python or Node installed on your computer, and you're trying to jump between them to test certain things. And if you mismatch one versus what you're running in production, you could get slightly different behaviors. And so the ability to run Python 3.10.5 specifically without having to worry about how to install that is a very valuable thing. To just have that interactive environment where I can test something out very quickly is another great use case for containers that you don't need to sort of do the full deep dive on how to optimize them for production, where you can still get benefit from them immediately.
Yeah, I love that second one that you had. I had never thought of doing that, of just spin up a container and that's you can go work on a different computer. So yeah, and going off of that third point, I think we'll take that one to the finish line here. You were talking about, having multiple versions of Python and whatnot. I think something that you can do on something like GitHub Actions in a CI/CD pipeline is you can run your whole pipeline through different versions, different containers. So could you maybe kind of wrap us up here by connecting the dots for people on, we talk about, containers. That's kind of one section of this profession. Then we talk about these pipelines that we, touched on earlier. How do these things connect? How do you take a container and incorporate that into one of your pipelines? What portion does that kind of slot into?
Yeah, there's two ways in which those two concepts come together. The first way is that many of the pipeline tools allow you to run the steps. I was talking about these steps in your pipeline. Those could run in a virtual machine. They could also run in a container. And so in that use case, it makes it easier to develop those steps locally, test out that they're working properly, and then run them in the pipeline accordingly. But I think the more common way that the containers come into play is if you're using them for deployment,
Right.
one step in your pipeline will be to build that container image. So take your application code. You talked about a Docker file earlier where you define all the necessary pieces that come together to build up your container image. So the build step in your pipeline is going to look at that Docker file, build out that container image, then push that container image to what's known as a registry. And so that's just a online repository where the eventual production environment can pull your image from. And then the final step, if you're deploying from that pipeline, is going to be to talk to your server and tell it, hey, there's a new container image available. Go ahead and run a new version of it. There's an alternate universe or version of that where instead of pushing my deployment from the pipeline, wherever my production environment is running could be looking at the registry and say, oh, I see a new version. I'm going to go ahead and use it, even though the pipeline had nothing to do with it. That's a sort of this pull-based deployment concept.
Yep.
But those are the places where your pipeline and the container images interact.
Awesome. Yeah. So that, kind of at that last stage. And I think to just kind of summarize what you're saying here, you've got this continuous integration and continuous deployment slash, what was your other, what was the other?
Delivery.
Delivery.
Essentially, the difference there is that deployment means you're actually deploying to production with each push, whereas delivery means you could deploy at any time based on the fact that you've brought the code in and you have a deployable artifact. Maybe you haven't clicked the button yet, but you could if you wanted
Well,
to.
and that's a good example of what you just talked about with, building up a container and getting this final image that's just ready to go and ready to be plopped on any, runtime that supports it. So, yeah, so this was a great kind of overview of DevOps, I think, and I think we'll cut it off here just at about an hour. So thank you for joining me here on the channel. And for anyone who is watching, once again, he has an awesome course on Docker. In the description, I've also linked Sid's channel, so be sure to go and subscribe to him. He's got all sorts of awesome content there. And is there any other place that you would want people to find you?
Yeah, I'm on Twitter. My handle is just at Sid Palas. So come find me there. I post about this stuff all the time. And then in addition to the video courses that Zach mentioned, I have a written version of those at courses.devopsdirective.com. There's the Docker course that just came out a few weeks ago. And then I have a Terraform course, which is an infrastructure as code tool that came out about a year ago that has been quite well received in addition to the Docker course.
Awesome. Cool. So I will get all of those links from you. We'll put them in the description. And if you're watching and you're a complete beginner, that's kind of a little bit over your head. First off, congrats for making it to this point. And second, Sid's got some awesome content. And the reason we're doing this collab is because I think he has a very similar philosophy to me of you got to figure out why you're doing something before you do it. So just trying to find more people here out on YouTube that are teaching things like that, and would highly recommend you spend some time over there on the DevOps Directive channel. And with that, I think we are wrapped up, and we'll see you in the next video.